Hi, this is section 3.1 in the syllabus. And we have a few different objectives that we are going to go over for section 3.1, but it mostly deals with graphs. And I have a quick video I'm going to show you that is a great visual representation of some of the things that are talked about in 3.1. So here it is. This video is examining the relationship between elevation and time, and the time is being measured in seconds, and I'm assuming the elevation is being measured in feet. Notice as the graph is plotting where he is in time with elevation, there are a few plateaus that happen on the graph, and these plateaus happen when he's not descending stairs. And so this was when he first walked out of his apartment, and then the first set of stairs that he went down, a short plateau for the platform here, and then he goes downstairs again, another short plateau, and then he finishes descending. Even has the curve right here. Great visual representation of a graph. Very easy to interpret this when you see it happening in real time, but not as much when you have the graph in front of you and you don't have a video to go along with it. But being able to interpret these kinds of graphs are important for this section. Okay, so going back to the objectives. Here's a couple graphs that you should be able to describe, and we're going to describe these kind of abstractly. So you don't really know what the variables are here, but we do know that the x-axis is representing the input, and the y-axis is representing the output. This one looks like we could describe it by saying as input increases, output also increases. And looking at the second one, the second graph here, we could say as input increases, use an arrow, output decreases. And then last we have this third graph that shows that as input increases, output stays the same. Okay, so here are some graphs. We love to call these curves, smiles, and frowns, but there actually is a name for these. We call these parabola. And although we're not going to be examining the equations that make a graph that looks like these, we are going to examine a few different vocabulary words when it comes to parabolas. And so this parabola, I guess in layman's terms, would be called a frown. But we also have this spot here, the turning point, which in this case we're going to call the local maximum. Now we can't see the end of this parabola, but these arrows here at the bottom are indicating that this goes down, 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 down forever. And so that would mean there never really would be a minimum. If you were looking for a minimum, you would not find it. This parabola is increasing in this area right here. the portion where it's increasing. There's a few different ways to talk about that. I guess you could say it's increasing for x values that are less than -2. And then from the point where it turns on, we would call this where it is decreasing. This is for x values that are greater than -2. The parabola here, the SMILE has a local minimum point. So you know another word for this point here, which is called the vertex. And this one is decreasing for x values that are less than 2. When x is less than 2. And increasing from here up, and that is when x is greater than 2. Okay, so here we have a graph that we could interpret. I just want to practice being able to identify what the input variables and what the output variables. Remember that anything that's labeled on the x-axis is what we are going to say is the input variable, and anything that is written on the y-axis would be called the temperature, which is the output variable. And this one looks like body temperature is usually around 98 degrees and goes down sometime in the morning and slowly, steadily increases. What could be happening right here at this point in time to make that body temperature dip? And my guess would be maybe that is when they take a shower, and maybe they take a cool shower. I'm not sure, it didn't dip very much, but that would be a great interpretation of what's going on in this graph. For the most part, that temperature hovers around 98 degrees. Okay, looking at another example, I'm already going to interpret the input as time and the output as net profit, just because I know the connection between x and y axis and the input and output variable. This looks like we're analyzing the net profit over a 2-year period, and the net profit dips in 2009. That could be my interpretation. The net profit decreases in 2009. I know in 2009 there was a recession. There are different kinds of conjectures I could come to as to why the net profit dipped in 2009, but I'm not exactly sure, so I'm just going to leave the interpretation vague. Introducing the idea of a function. This is the whole underlining objective for 3.1. A function is a rule that relates an input variable and an output variable in a way that assigns one and only one output value to each input value. We're going to look at relationships that are in the picture of a graph. And so we have this test that we use to decide whether or not a relationship is a function, and it's called the vertical line test. So I'm going to draw a vertical line, and I'm going to show you how you can use this vertical line to figure out whether or not you're looking at a relationship that is a function. So looking at A, the relationship is linear, and I'm going to take my vertical line and I am going to run it across the relationship to see if it runs into this vertical line more than once at a time. And so as I'm running it, I'm saying to myself, it's hitting it once, 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 and I'm going to say, yes, this is a function. Matter of fact, any line, as long as it's not a vertical line, but any line that you see that's graphed would pass the vertical line test, as long as it's not a vertical line. I'm taking my vertical line again for B, and I'm noticing that as soon as I get past that point where they intersect, that now I have two spots where the relationship intercepts my vertical line, and so I'm going to say that no, this is not a function. I'm taking my vertical line and putting it through the test for C, And even though C gets quite steep here towards the end, it's not a vertical line, so this is going to be a function. Everywhere I run my vertical line, it only hits the relationships once at a time. D, a circle. Circles never pass the vertical line test, so this is not a function. You could possibly see word problems that are asking you to analyze a graph and decide whether or not it's a function. This graph is analyzing the height of a roller coaster in relationship to the distance from the starting point. And if I run my vertical line along this, it starts to pass the vertical line test until I get to this area right here, where it would hit my vertical line more than once. And so I would say, no, this is not a function. And that is section 3.1.